Hey guys, Mr. Riz here to help you out on the last part of the 3.3 note. So this is the complex numbers from Algebra 2, the state standards that we need to go over. So we did a lot of warm up. Hopefully this becomes a little bit easier now. All right, so if you guys want to warm up here, let's simplify these simple expressions with x's here. Let's make sure you guys can do that. So pause the video, give it a try. Okay, first one, we got to combine like terms. So we got 2 plus 5 gives us 7. And then negative 3 plus x is negative 2x. When we're dealing with subtraction, just be careful. Order of operations here. We got 7 minus 6 gives us 1. And then negative 3 minus 4, which would be negative 7. All right, same thing here with addition. We got negative 1 plus negative 2 gives us negative 3. And then 5 plus negative 8, 5 minus 8 would be negative 3x as well. Now over here, we would have to FOIL. And so we would end up getting, well, let me get my writer out here. All right, we distribute here. 2 times 5 is 10. 2 times x is 2x. Negative 3x times 5 is negative 15x. And then negative 3 times x is negative 3x squared. And we can combine the middle term together. That's how we get the minus 13 in the middle. Now, number 5 is a very common mistake. You might see, hey, I just got to square that and square that. There we go. But really, negative 2 minus 8x squared is negative 2 minus 8x times negative 2 minus 8x. If you write it like this, you can see you got to FOIL. Negative 2 times negative 2 is a positive 4. Negative 2 times negative 8x is a 16x. Negative 8x times negative 2 is also a 16x, and negative 8x times negative 8 is a positive 64x squared. Combine the two middle terms to get that middle 32. Alrighty. So goal here is we're going to be looking at complex numbers. Make sure we can deal with complex imaginary numbers and just other operations here. So we've said this before, some equations don't have real solutions. Ones that do not cross the x-axis are going to have solutions that are not real. And this is where we're going to determine, what are those values in imaginary units. So the square root of negative 1 is going to be our imaginary unit that we call I. And so the good thing to know here is that I is equal to the square root of negative 1. And what we've talked about before is that I squared is equal to negative 1. All right. And the way that we can write these imaginary numbers is just purely by looking at what they are as an imaginary unit. So we can call them like 6i, negative 2i, or I radical 3. So where we have some number that is real with an imaginary value multiplied onto it. One thing to kind of note here too is that, okay, we can have some power rules here going on. So we know I is the square root of negative 1. I squared is negative 1. If I have I cubed, really that is I squared times I. So I can make that a negative 1 times I or a negative I. So I have I to the fourth power. Think about what that would be. It'd be I squared times I squared. Negative 1 times negative 1 is a positive 1. And we could keep going on forever there. All right, so if you need to go through, give this a try. Try to simplify the square root of negative 294. So what we want to do here is to break this down. Now, we know our answer is going to have an I, but we're still going to break down the 294. So 294, I'm not sure. I'm going to take out a calculator, divide it by 2. I know it's even, so I can divide it by 2. 294 divided by 2 is 147. All right, I can't divide 147 by 2 because it's not even, but can I divide that by 3? Yes, I can. It's 349. 49, I know, is 7 times 7, and that's all we can break down. So we look at our partners. We have a 7 that breaks out, a 2 and 3 stuck inside. So the 7 goes outside with the I, because we had the negative on the inside, and the 6 stays inside. So we have 7i radical 6, or 7 radical 6i. All right, next, give this one a shot here, guys. See if you can do this. So pause the video. What is the square root of negative 75? All right, let's check our answer here. When you break it down, remember what an I is going to go out, and then we're going to break down these radical 75, and we should get C. We get a pair of 5s and a 3 left over by itself. Should be 5i radical 3. All right, how do we multiply two imaginary numbers? All right, so first thing we're going to do is to make sure that we do take out the i's. So we're going to have I radical 10 times I radical 15. The I times I is going to be an I squared, and then 10 times 15 is 150. Break down the 150 is 15 and 10, 5 and 3, 5 and 2. Got a pair of fives with twos left over. So the 5I squared radical 6. We just got to remember that the I squared does become a negative 1, so this should be a negative 5 radical 6 as our final answer. Why don't you guys try the next one on your own? What is the square root of negative 16 times the square root of negative 25? Pause this video, see if you guys can figure it out. Should get an answer of negative 20. So we multiply, we got I radical 16 times I radical 25. You should get I squared radical 400. And 400 breaks down nicely. You get a bunch that breaks out, nothing left over, and the I squared becomes a negative 1. All right, so now, okay, how do we get like these pure imaginary solutions? So if we were to graph this equation here, even I'll show you on put decimals up. We got x squared plus 81. All right, this graph does not cross the x-axis. It's all the way up there. Doesn't mean that we don't have solution, just means we don't have a real solution. So we can still figure this out by solving or getting the x squared by itself by first subtracting the 81. We get x squared equals negative 81. And then to get rid of a square, we can take the square root. Now, whenever we take the square root, we need to put this plus or minus sign here because we're going to have a positive and we're going to have a negative answer here. Because remember, like 9 times 9 is 81. Negative 9 times negative 9 is also 81. So we got a positive and a negative answer here. And since we have the I here, or the negative, we are going to get a positive and negative 9I. So there's our solutions. There are our roots, imaginary roots to our example here. All right. Now, if it's a little bit more complicated here, you can try this next one on your own if you're feeling it. We're still going to do the same steps. All right. If that was just 3x plus 27 equals 0, we would minus the 27 over. All right. Then we divide by 3. And now that we got the x by itself, we're going to take the square root. When we take the square root, we need to do two things. We need to remember the positive and minus sign. And then, okay, what's the square root of 9 is 3. Since it's negative, we're going to put a 3i. So two answers here. One is positive 3i, and the other one is negative 3i. So right there, we're introducing these ideas of complex numbers. So complex numbers are always written in the form of a plus bi, where a is the real number and b is the imaginary unit. And notice that you always put the real number part first. So in a Venn diagram here, if we're looking at, real numbers, first we have like, our real numbers and our imaginary numbers. And then pure imaginary numbers are the ones that are very similar to this, except for, we can't have a b equal to 0. So we always have a real number part that could be natural number, whole number, even just like a radical or quotient. And then we have some imaginary or we also could have some irrational numbers there, the square root. So pretty much the order goes the real numbers, the square roots, and then the imaginary part. Complex numbers are equal if and only if their real parts are equal to their imaginary parts. So we can look at things like distributive property and multiplication property, pretty much the same thing, but anytime we're adding, subtracting, we just look for the real parts to combine with real parts, imaginary parts to combine with imaginary parts. The complex conjugates are used, like we talked about with dividing, to help rationalize the denominator, because denominators can never be a fraction. The denominators can never be a integer or not an irrational number, and the denominators cannot be a imaginary number. So we might have to go through and change some things up. All right. Let's see. Actually, we don't need to. Well, you guys could probably figure this out here. What would have to be the values of x and y to make this true? If we got 7x or 5 minus 7x plus y, So the real part, we would match up with the real part. And the imaginary part, we'd match up with imaginary. So we'd have to go through and see, okay, 5x minus 7 is going to have to equal 13. That's the real part. And then the imaginary part here is going to match up with the imaginary. Y plus 4 would have to end up equaling 11. So if we go through here, let's see, add the 7 over, 5x would equal 20, divide by 5, x would have to equal 4. And then over here on the other side, just looking at the imaginary, we subtract the 4 over from the 11, and it would be 7. Not too bad. So just remembering here, we keep reals with reals and imaginaries with imaginaries. So if you guys want to try this next one on your own, see if you guys can do it. What would x have to be to make the real part end up being -2? And what would the y have to be to make the imaginary part equal to 1? Not 0, but 1. All right, x would have to be -3 because 5 times -3 plus 13. All right, -15 plus 13, that is -2. And y would have to be 4 because 2 times 4 is 8, and 8 minus 7 is 1, and that matches up with the imaginary number there. All right, now when we're combining like terms here, adding or subtracting, we just look at like if they were x's. We can combine the x or the regular real numbers together. 8 minus 4 is 4. And then we can combine the imaginary parts together. 3 minus -10 would be 3 plus 10. So we get 13i. So we just use the normal terms that we do before. We're just simplifying along the way. Okay. If you want to go ahead, give this one a try. Pause the video, see if you can do the same. Remember, only combine real with real and imaginary with imaginary. We combine the real with the real, we got -5 minus -3, which becomes a -2. Be careful, that'd be like -5 plus 3. And then 5i minus 8i would be a -3i. So there's your real part, there's your imaginary part. Now, when we are dividing, we have to multiply by complex conjugates. So the complex conjugate is going to be the opposite of the expression on the denominator. So we got 3 minus 2i that we're going to multiply the top and bottom both by. Now on the top, we need to distribute the 5i. So we get, let's see, 15i minus 10i squared. The bottom, we got to FOIL this out. 3 times 3 is 9. 3 times minus 2i is minus 6i. 2i times 3 is a positive 6i. 2i times -2i is a -4i squared. Next, what I like to do is let's simplify, combine like terms, or change our I squared. So if I got 15i, and if I had minus 10i squared, that's going to become a plus 10 because the I squared is going to be a -1, which is going to turn the -10 into a positive 10. And at the bottom here, we can combine these like terms, so it actually cancels each other out, and then we get 9 plus 4. Now what I'm going to do is I'm going to put the real number part first. So I'm going to put a 10 first and then 15i on the top, just putting it in the proper order. And the bottom becomes 13. And then the last thing you're going to do is see, you're going to divide both of those terms by the denominator 13, which we end up just getting fractions. So we get 10 over 13 plus 15 over 13i. And there's the answer. All right, once you guys pause the video and try the next one on your own. Okay, what's 2i divided by -4 plus 3i? All right, the complex conjugate should be -4 minus 3i. And when you do that, you end up getting an expression here of 6 minus 8i or 25, which is 6 over 25 minus 8 over 25i. All right, so there's a video here. We've spent some time on this. If you've watched all the videos from 3.3, thanks for watching. 3.4 is going to be another longer section here. So you guys have a great rest of your day, and I will see you guys later. Bye.